The removal of undesirable impurities associated with the organic compound is known as purification. The filtrate contains impurities, the crystals formed are removed and dried. After vaporizing, there is a condenser attached to the conical flask, so it will be settled down there. Nature of liquid and impurities, three kinds of distillation will be seen. That one, fractional distillation, steam distillation and distillation under pressure. Hello everyone, this is Harshita Bhavasar from Vidhyaashram PU College, Temple of Excellence. Today we are starting up session 6 from the chapter Organic Chemistry, some basic principles and techniques. So, in the last class, we have discussed about electron displacement effects in covalent bonds and types of organic reactions. In the electron displacement effect, the types of effects are inductive effect, resonance effect, like mesomeric effect. Every kind of effects we have seen in the last session, as well as we have looked upon about addition reaction, elimination, substitution. These are all the types of organic reactions we have seen in a detailed manner. So, in this session, we are discussing about methods of purification of organic compounds. So, in that, distillation, sublimation, crystallization, differential extraction and chromatography. These are the various methods to purify the organic compound after the synthesis. Okay. So, we will study one by one now. What is purification technique? We will see. The removal of undesirable impurities associated with the organic compound is known as purification. See, after the synthesis of organic compound in a laboratory, there is a presence of a impurity in it, okay, or undesirable compound will be present in it. So, it should be removed from the desirable compound, whatever we need that compound, from that the undesirable impurity or undesirable compound should be removed. That technique will be called as purification. So, to do that purification, the various methods are applied for the purification of organic compounds. Which are those? Those are distillation, sublimation, crystallization, differential extraction and chromatography. Okay. These are the 5 major techniques we will use for the purification of organic compounds. First one, we will see sublimation. Okay. What is that process and how it will be happen means, the process of separation of volatile solids from non-volatile impurities on the basis of the tendency of volatile solid to pass into the vapor state without melting is known as sublimation. Means a process of separating a volatile solid is nothing but a solid without getting melting, it will be converted into its vapor state. That will be called as volatile. In that solid is there. For example, naphthalene, camphor. If you ignite the camphor, what it will be happen? Directly it will turn up to its gaseous state without any melting. So, it's a best example for sublimation. The impurities whatever are remaining in the dish will be called as impurities. Okay. It will be on the basis of volatile solid to pass into the vapor state without any melting is known as sublimation. Example, volatile solids such as benzoic acid, naphthalene, anthracene, camphor. In homes or in a domestic way, we will use usually camphor and naphthalene. We have seen that. Okay. See here, this is a china dish. In it, they have used ammonium chloride. Okay. This is a burner. If we ignite that one, the vapors directly from the solid, it is moving into vapors. Here, cotton plug has been fixed because it should not get completely come out from the, this is inverted glass funnel. Okay. Here, this is the required or desired solid and the remaining whatever after sublimation, this will be impurities will remain. Next is crystallization. The impure compound dissolved in a solvent in which it is sparingly soluble at room temperature but appreciably soluble at higher temperature. The saturated solution on cooling or when allowed to stand for a long time, pure compound crystallizes out and it is removed by filtration. The filtrate contains impurities, the crystals formed are removed and dried. Okay. What they are telling means the impure compound, whatever it is not needed for our next research, it will be impure compound, will be dissolved in a solvent and it will be sparingly soluble at room temperature but appreciably soluble at higher temperatures. Okay, that will be impure compound. But the saturated solution, whatever the saturated solution will be there, completely soluble solution, that will be after cooling, if you allow the time to stand for a long time, the pure compound will get crystallizes. After that crystallization, you have to filtrate, and the filtrate whatever will be present in the after staining, that filtrate will be impure, that solution will be pure compound, that should be removed from that impure one and it should be dried. Best example is sugar and phthalic acid. Sugar, if you see, it will be in a crystalline structures. How it has been processed? By the process called crystallization. See this one. This is impure solid and it is solvent. They are stirred to dissolve in it and they are evaporating in this evaporation basin. Okay. Step 3, they will allow some time to settle down. This is a crystalline or crystal formation line and they will filter this one. After filter paper, they will do the drying and processing of crystals. Okay. Next one, distillation. This method is employed for the separation of volatile liquids. See here. This method is completely employed for the separation of volatile liquids which do not decompose at their boiling points and contains non-volatile impurities, also for the separation of two liquids having sufficient. In this method, a liquid mixture is heated. The liquid with low boiling point vaporizes first. The vapors of the liquid are condensed and collected in a receiver. Here, two liquids or two solutions will be mixed, or if it is getting mixed, they have to separate. How they can separate? Because those are volatile liquids. Means if the heat is needed or if heat is provided for that liquid, it starts getting vaporized. Both the liquids are volatile liquids in a comparable version. Okay, and which do not decompose at their boiling point. If you give some normal heat only, it will start vaporizing. Okay, in that presence of impurity will be non-volatile. Okay, this is the criteria what they have given here, and the liquid with low boiling point will vaporize first. After vaporizing, there is a condenser attached to the conical flask, so it will be settled down there, and we have to stop that evaporating that one, or else if we keep on going giving that heat, another liquid also get mixed again there. There is no usage of doing distillation. So what they are telling, after giving the low boiling point, the first liquid will be evaporated and the second liquid will be remain as such. Okay. Mixture, example, chloroform and aniline and ether and toluene. See this picture. Here mixture is there and the thermometer. This is, we will call it as round bottom flask or RB flask. And after giving the heat, here it starts moving to the receiver, the liquid substance. Here water inlet is there, or to the sink also we will give, the impurities will go out. And we have to stop after one liquid with a low boiling point has been separated here, or else two liquid also come here and it get mixed here. There is no use. So, after getting one solution with low boiling point has been separated, we have to stop this flame. That's why here one liquid will be get separated, another liquid will be present in this conical flask. Thus, how two volatile liquids get separated from the mixture. So, depending upon the nature of liquids and the impurities, one of the following distillation methods are used. That what distillation we saw, that is a general concept of distillation. Based on nature of liquid and impurities, three kinds of distillation will be seen. That one, fractional distillation, steam distillation and distillation under pressure. So first one, we will see fractional distillation. This method is used for separation of liquids from the liquid mixture which have boiling point close to each other which differ by 15 to 16 Kelvin. Here also two liquids will be get separated from the mixture which is having the boiling point near to 15 to 16 Kelvin. In this method, vapors of the liquid mixture are passed through fractionating column before condensing. When the vapors of the two liquids move up, the vapor of the liquid with high boiling point condenses in the fractionating column and only the vapors of the liquid with low boiling point passes through the fractionating column and gets separated. See here, the principle of the fractional distillation is the same, means the two liquids get mixed or two liquids which have been already mixed will be get separated. Around that two liquids will be around 15 to 16 Kelvin. Here they will use fractionating column before condensing, okay. With the high boiling point, whatever the high boiling point liquid is present, that will be remain in the fractionating column itself, which the liquid is having low boiling point, which will passes through the condensation will takes place and it will be come out for the outside conical flask, okay. That's how the two liquids get separated. Example, mixture of benzene and toluene or methanol and propanone. Distillation of petroleum, coal tar and crude alcohol is also done by this method. These are the applications of fractional distillation. Next one, steam distillation. This method is used to separate liquids which are steam volatile and are immiscible with water. Immiscible with water. Immiscible means that will be used for the term liquids. Immiscible in the sense one liquid is not getting mixed or mixed with another liquid like water and sugar solution or something, okay. How it will be, oil and water will be present like that. And when steam is passed through the heated liquid, the liquid vaporizes well before its boiling point and gets separated. The vapors containing steam and the liquid are condensed and then separated using separating funnel. Steam distillation is based on the principle of Dalton's law of partial pressure. Means here they are using steam, okay, they are using steam volatile and those will be immiscible with water, and overall when steam is passed, through the heated liquid, the liquid vaporizes well before its boiling point. It will start vaporizing, the liquid mixture will starts vaporizing before its boiling point will be started. Okay, the vapors containing steam and the liquids are condensed and then separated using separating funnel. That is how after giving steam and all that start separating, they will start. This principle will follow Dalton's law of pressure. Means P total equals to P1 plus P2. Example, aniline, nitrobenzene are purified by this method. Next is distillation under reduced pressure. This method is employed for the purification of organic liquids which have very high boiling point and decomposes at or near their boiling point. In this method, the liquid is made to boil at a lower temperature than its normal boiling point by reducing the pressure. Here what they are telling, this method is completely employed for the purification of organic liquid which have very high boiling point and decomposes at or near to the boiling point. It will decomposes at the boiling point which is having high boiling point, and in this method they will boil in the lower temperature. The liquid should boil in a lower temperature rather than normal boiling point. Whatever the liquid is having its normal boiling point, lesser than to that it will starts boiling by reducing the pressure. Here no pressure is applied like before steam distillation. Example, glycerol is separated from spent I in soap industry by this method. Glycerol decomposes at boiling point 563 Kelvin under atmospheric pressure. It can be distilled without decomposition at 453 Kelvin under 12 mm of mercury pressure. Okay. Usually glycerol decomposes at 563 Kelvin. Without decomposition, it can be distilled around 453 Kelvin. That is how without pressure they are doing. Next one is differential extraction. It can be also called as solvent extraction. Okay. The separation of an organic compound from its aqueous solution by mixing with a suitable organic solvent which is immiscible with water is known as differential extraction. Means here also the extraction of or the separation of organic compound from its aqueous solution. Aqueous solution means that compound should be mixed with that water will called as aqueous solution with a suitable organic solvent. It should be mixed with suitable organic solvent, but it should be immiscible with water. Means the organic compound should dissolve in suitable organic compound without water or in the absence of water, and they have to be get separated. This method is employed for the separation of benzoic acid from aqueous solution using benzene. Okay. Organic layer is dried over suitable dehydrating agent for the separation of which depends on the nature of organic compound. See here, this is a separating funnel. Okay. Here organic compound in aqueous layer is present, is the solvent layer. When it gets miscible with solvent layer, see here organic compound in solvent layer, the color will change and this is a aqueous layer. That water layer will be get separated and here the compound will be present. This is before extraction and this is after extraction. Next is chromatography. Here chrome means nothing but color, graphy means writing. Okay. This is an important technique used to separate components of the mixture to purify the compound and also to test the purity of the compound. Here the chromatography is an important technique because by this three things you can observe: components of the mixture and purity of the compound and also how the purification has been done. You can check from that also. In this technique, the mixture which has to be separated is applied on a stationary phase. It may be solid or liquid. Usually silica gel or alumina will be used as a stationary phase. A mobile phase is allowed to move slowly over the stationary phase. Okay. It may be solvent or a gas. The components of mixture gets gradually separated. This technique is called as chromatography. Stationary phase is nothing but it will be fixed in some place. It is used as solid or liquid. Usually they will use silica gel or alumina. Okay. Next, pure solvent or mixture of solvent will be used as mobile phase. There are two kinds of chromatography. One is adsorption chromatography and partition chromatography. We will see here adsorption chromatography. Principle: different compounds are adsorbed on an adsorbent to different degree. In the different degrees, the different kinds of adsorbed will be seen. Types of adsorption chromatography. Column chromatography, first one we'll see. Okay. In this method, the mixture to be separated is placed in a column as shown in the diagram and a liquid called eluent. Whatever the liquid is used, that will be called as eluent, is allowed to flow down the column. Different columns are formed depend on the degree to which it is adsorbed. The most readily adsorbed substance is retained near the top and remaining substance move down to different points in the column. What should be needed for or readily it is retained will be at the top, which is not needed, it come to the bottom. See here, this is a mixture of ABC, that is compounds, mixture of compound. For that solvent, we will call it as eluent, they have used. And this is stationary phase, adsorbent. They have mixed here, they have allowed that mixture, later that solvent is used. Here glass, it is a glass and wool is used, cotton plugs will be used. And they will start solvent, the eluent will be poured here. It starts getting separated. See here, A is separated, B plus C, next A, B and C. The separation of mixture gets started by this solvent. Okay. This is column chromatography. Next is thin layer chromatography. It will be called as TLC. In this method, a thin layer 0.2 mm thick of adsorbent is spread over a glass plate of suitable size and it will be called as chroma plate. A small spot of the mixture is placed about 2 cm above at the one end of the TLC plate. The plate is placed in a closed jar containing the element. A solvent is used for the separation of components of the mixture. See here, this is a chroma plate which will be a paper, a 0.2 mm thickness. One dot should be put and it should be immersed in a solvent, and you have to leave some time and you have to close the lid. It will be in a contained jar, closed containing jar, so it starts getting separated. See here, it is a origin where the dot has been given, that separation has been seen. 2 cm at the 6 cm, 8 cm and 10 cm. This is a solvent front side you are seeing. Okay, that is how the components get separated from the mixture. This is called thin layer chromatography. Next is partition chromatography. It's a second type of chromatography in the classification. What does the principle says? It involves the continuous differential partitioning of the components of a mixture between stationary and mobile phase. Not only a one time, it will be continuously doing. So example, paper chromatography. In this method, a spot of the mixture is placed in a special type of chromatography. Paper contains water trapped in it, as in the case of TLC. Similar to the TLC only, means thin layer chromatography. This paper strip is suspended in a suitable solvent, which is a mobile phase. Okay. Depending upon the selectivity, the different components are separated. This paper strip is known as chromatogram. There, one normal thickness of 0.2 mm of thickness we have seen. Here also paper will be used in the paper chromatography. Okay, the solvent will be used as a eluent. Based on the selectivity, it will start the components getting separated. It is similar to the thin layer chromatography only. Here also you have to do the spot. You have to see the components, individual length of the components from the solvent front side. See here, this is a beaker where the filter paper has been fixed, and this is a spot, this is a solvent. Okay, you have to leave some time, it will start up. Okay, this is solvent. No, here individual pigments get traveling. This one you can see in the chlorophyll, in that xanthophyll A, xanthophyll B, chlorophyll A, B, like that you can see nicely in this experiment. That is the best example. In the chlorophyll, how many pigments are there? Those will be seen in this experiment. So these are the overall techniques and classification of chromatography, as well as the purification methods like distillation, sublimation, crystallization, and overall methods. So in the next class, you will study about qualitative analysis of organic compounds and quantitative analysis of organic compound. Okay, we'll see in the next session. So I hope you have understood whatever I have taught today. So thank you so much.